Hello, my name is Alex, and this is my Python program for following the projectile motion of a ball thrown at an angle. Alright, for this first line of code, we're just creating the floor where we're going to start our ball and where it's going to end. Here we're actually creating our ball. Now we're starting it a little off-center towards the left. That way you can see the full curve as it goes across the screen. The radius of our ball is 0.2. We're making it red, and we're going to make it show to where there's a trail following behind it. Now, the mass of our ball, or ball.m, is going to be 0.1. Now, keep in mind that that is in kilograms. Our initial velocity, v0, is going to be 4, which, of course, translates over to 4 meters per second. And our theta, which is the angle at which we are throwing our ball, is going to be 60 degrees. Now, I went ahead and I assigned the ball's velocity. Well, we already have the velocity, but we got to have it as a vector because it's got to know where it's going. So, we're taking our initial velocity and we're going to multiply it by our angle, which we already programmed in here with theta. So this way, we've got the x direction, left to right, and then here, we're multiplying our initial velocity by our y direction. That's going to give us our up and down. Now, a little bit farther down, we have gravity. Now, the gravity vector is, of course, 0, negative 9.8, and then 0. However, it's 9.8 newtons per second. Now, our time step, which is what this is, our delta t, our change in time, our time step for each calculation, we're doing 0.01 of a second, or a hundredth of a second. Now, we can't apply the full gravity to that the entire time, otherwise this would get crazy. So you have to multiply it by our time step, so that way it changes in proportion to where it should be. And of course, we're going to start our time at 0. Now, right here is a fun little thing where we're going to keep track of the highest point of the ball's travel. And here's our air time, or how long it takes for it to go up and land. Alrighty, and this is our loop. Now this is what's doing the most of our work here. Our rate is 100, which means we're only doing 100 calculations per second. Now, this would be kind of impossible for a human to do, and hence why we're doing this program. Now, this one and this line are kind of fun. Those are just what's necessary to find out what our maximum height is. Essentially, you have your initial height, which is before most calculations are done, after the position updates, and then the second one. So you have your updated position and your previous position. Now, what I have here for this if statement is if your previous is above your current, which means it's going down. If your previous is above your current, that means you might have started up here, and now you're right here. Now, if that's true, then your max height equals y1. Now, notice, because of how I have it, as you're going up, it continuously updates. Then as soon as it drops, it keeps whatever that highest is. Now, this else statement is just for fun. Just essentially do nothing. Alright, right here, we're updating our velocity, which it's moving, and of course, it has gravity acting on it each time. And here we're updating our position. So our new position equals our old position plus the velocity times our time step, which is of course a hundredth of a second. Oh, there it is, hundredth of a second. And then we're updating our time. If we start at 0 after a time step, we're at 1.01 seconds, then 1.02 seconds. So this just keeps track of where we are. Now this also keeps track of the total time it's in the air, because as soon as this loop stops when the position is 0, or less than 0, but hopefully it catches it at the 0. Once it hits the 0, it stops, and for that we keep track of our time. So once we get to the end of our loop, which you can tell we're at the end because we stopped indenting, if you can see that. Now then we have our 3 print statements. Our first, the ball traveled. Now this keeps track of our x. Now we added 1 because if you remember up here, we started a little to the left, so that way our image would be centered. So, ball traveled x amount of distance. Now we throw in our max height to get that. And then we have our air time, which we're just plugging in t. So let's go ahead and see what this does. And as you see, the reason we start at the -1 is because the 0 is about right here. So we see that the ball traveled 1.4. We got these floating points throwing off. And then it goes to a maximum height and your air time. And that is how you program this.